Good morning, dear students. I am Dr. G. Vijayalakshmi, Mathematics faculty. Today I am going to explain the equations of first order and first degree. There are two standard forms of differential equation of first order and first degree. The first form is dy by dx equal to f of x comma y, and the second form m of x comma y dx plus n of x comma y dy equal to 0. Using the second form, we are checking the working rule for solving an exact differential equation. Here in dx, before whatever the terms are existing, that we'll treat it as m of x comma y. Similarly, dy, before whatever the terms are given in the question, we'll treat it as n of x comma y. One thing we need to focus: the middle sign must be positive and it must be an equation. If it is not an equation, we need to convert to the right hand side values to the left hand side, and we have to make it as equation. Using this form, I am going to solve an exact differential equation. Before going to solve, we need to know how to simplify the problem by using this method. For the exactness, we need to find out, we'll compare the given question with this equation 1, and we'll find out what is m and what is n from that. Once we get m and n, we'll differentiate m partially with respect to y, and we'll differentiate n partially with respect to x. Once these values two are equal, then we'll say the given differential equation is exact. Once it is exact form conformed, that means dou m by dou y and dou n by dou x values are equal. From there, we'll write the general solution: integration of m dx plus integration of n dy equal to c. But before going to integration of m, we need to suppose in the place of this y is constant, and before going to do integration of n with respect to y, we need to consider the terms which are not containing x. Using these conditions, we need to find the solution of the given equation. This is called exactness method type 1. So before going to solve this problem, here I am taking one example of same method, whatever the method I explained now. So here I am considering one equation: y into sine 2x dx minus y square plus cos square x dx dy equal to 0. This is a given question, equation number 2. We'll compare equation 1 and 2. If you check the question, the middle sign is minus. For exactness, we need middle sign must be positive. So the given question we'll rewrite by using taking the positive sign outside and negative side inside the given function, and we'll make it as equation. Now the given question, if we compare with equation 1, we'll get m as y sine 2x and n as minus y square minus cos square x. As I told earlier, the working rule, the type 2 is we have to check for differentiation partially with respect to y for m and differentiate partially with respect to x for n. Then dou m by dou y, because it's a partial differentiation, the variable with the same differentiation will differentiate, the remaining variables will treat it as the constant. Here sine 2x is constant because we are differentiating with respect to y. So differentiation of y is 1, therefore dou m by dou y is equal to sine 2x. Now we'll check for n, dou n by dou x minus, already mentioned, same variable will differentiate. If other variable, we'll take it as the constant. Minus, what is differentiation of cos square x? 2 cos x. What is cos x differentiation? Minus sin x. So it becomes plus. Now differentiation of constant is 0. So 0 plus sin 2x. 2 sin a cos a is sin 2a. Therefore, we got it the answer as dou m by dou y equal to dou n by dou x. So the given differential equation is exact. Once it is exact, we'll go for the general solution. Here we are calling as general solution. Why? Because the order is 1, the number of constants also we are supposing as 1. That's the reason we call it as a general solution. So, what is a general solution for this? Integration of m dx, we'll treat y as constant. In this not containing x terms for n dy equal to c. So, what is m? Y sin 2x dx as y constant plus minus y square minus cos square x dy equal to c. I told you there is not containing x terms. If you observe this, x is there, but this is cos square x. So y is constant. What is integration of sin 2x dx? Integration of sin is minus cos 2x, x coefficient is 2. Because of integration, we will write the constant in the denominator. Now what is integration of y square? Dy minus integration of 1 plus cos 2x by 2 dy equal to c. What is integration of y square? With respect to y cube by 3 minus 1 by 2 integration of 1 dy, and because x is present, you are not supposed to consider, we'll make that one as 0 and equal to c. So the final answer is minus y cos 2x by 2 minus y cube by 3 minus 1 by 2y equal to c. This is called the general solution of the given differential equation.